in this section we're going to talk about absolute value functions. If you recall, when we defined f of x equal to absolute value of x, it's like if I have f of x or y is equal to absolute value of 2, means you locate 2 on the number line and you find the distance from this number to 0. So that would be 2 units. So absolute value of 2 means 2 because that's the distance from this number 2 to 0. Absolute value of minus 2 also is equal to 2 because we are really talking about how far negative 2 is from 0, because the distance is always a positive number, still would be 2 units. So absolute value of minus 2 also is equal to 2. So look, when a, or this number here inside the absolute value, or call it x in this case, if x is positive, if x is greater than 0, greater or equal to 0, the result would be the number itself. That would be absolute value would be equal to x. However, if x is negative, like in this case is negative 2, the result would be opposite of this number to ensure that we get a positive number. So therefore, if x is less than 0, absolute value of x equal to negative x. So we're going to use this concept to define absolute value of a function. So instead of a number or single variable, we are going to have a function there. So absolute value of f of x also would be equal to f of x if f of x is greater than 0, and would be opposite of that if f of x is less than 0. So those of you using the technology calculator, a lot of time absolute value is referred to ABS of x. That means absolute value. In a lot of calculators they use that. So to graph the function of form y is equal to absolute value of x, we leave the graph of f unchanged for the portion of the graph that are above x-axis. Remember we said if f of x is positive, we don't change that. The result would be just the f of x itself. However, if it's negative, we need to reflect that respect to x-axis, and we reflect the portion below the x-axis across the x-axis. The domain would be the same for both. However, the range would be different. It would be subset of that. That would be a subset of the interval between 0 and infinity. This would make a lot more sense once we look at the example. So let's take a look at this example. Here we have y is equal to x minus 4 square minus 3. This is a graph of a parabola that shifted 3 units down and 4 units to the right. We already know how to shift the parabola now. So the portion that are positive from here to here is positive. You see the function doesn't change. We're going to keep it as is, so as this portion here. But the portion that is negative, which is this portion here, we need to reflect that above the x-axis. We want to make it opposite of that, remember? So that would reflect up here. So that would be the graph of absolute value of that function. And you can see the domain would be the same, all value of x. The domain doesn't change. However, the range was originally from negative 3 to infinity. Now it moved from 0 to infinity. So let's take a look at this graph here. This is the graph of f of x. We want to graph the graph of absolute value of this. So this portion here is positive. I'm not going to change it. However, this portion here and this portion here that are negative, we need to reflect that above the x-axis. So this portion is the same. I didn't change it. This portion, when you reflect a graph across the x-axis, means you take any point from this and you change the y to its opposite number. X stays the same. So the point 1 and minus 3 would turn to 1 and minus 3. Opposite of 3 is minus 3. Like this point here, 0 and minus 2, that would change to 0 and plus 2. So the graph would reflect across the x-axis. So this would be the graph of absolute value of this function. You notice that the domain is the same, is all real numbers here. However, the range being from this point here, -3 to infinity, would change to 0 to infinity. Graph each equation, then comment on how the graph are related. Right, y is equal to 2x minus 1. That's easy graph. The intersection is -1. My graph going to pass through point -1, and my slope is 2. Rise over run, 2 over 1 from any point on the line. If I move 2 units up, 1 unit to the right, I can get back to another line. Or I can graph that by selecting some points here. So everybody should know how to graph y is equal to 2x minus 1 here. Now the graph of 2x minus 1 absolute value of this function, remember we're going to take the positive portion unchanged. From here to here would be the same, except this portion here, would be reflection of x-axis. If I take this portion here and reflect it on x-axis, that would give me the graph of that function, which is right there. And that should also make sense. This would be a graph of absolute value of 2x, which shift this to the right 1 unit, and it also shrunk a little bit because of this factor here. But we use the fact that we looked at the y is equal to 2x minus 1 to graph absolute value of this function. We're just going to take the positive portion alone, and the negative portion we're going to reflect it around x-axis. So that's how we can retrieve the graph using this fact. So the graph can be obtained by reflecting y is equal to 2x minus 1 across the x-axis. So if I have absolute value of 2x plus 1 is equal to 7, if you have absolute value of x is equal to 7, let's take a look at it, make it a little easier. If I have absolute value of x equal to a number 7, that means really all the numbers that are exactly 7 units away from 0. So if I were going to graph this, I would find one number here, 7, is exactly 7 units away from 0. And there's another number here, -7, also is exactly 7 units away from 0. So if I have absolute value of x equal to 7, x would be equal to 7, or x equal to -7. These would be my solution. So in general, if I have absolute value of x equal to k, x would be equal to plus and minus k, k being that number. So in this case, instead of x, we have this expression. So what we have to do is we have to say, I'm going to take this expression, 2x plus 1, and let it be equal to 7, and then also let it be equal to -7, and then simply solve for x. And if we do that, you get x equal to 3, x equal to -4. If I go ahead and substitute these values for each x3 and for each x -4, you can see that would add up to equal to 7. So the solution set would be a -4 and 3. Those are the two solutions. You can use your graphing calculator to obtain the same result. In this case, y1 would be absolute value of 2x plus 1, which is equal to 7. So y2 is equal to 7. So if you let your calculator graph these two lines, the point of intersection would be your solution. So this graph would be the graph of absolute value of 2x plus 1, and this would be the graph of the line y is equal to 7. As you can see, these two graphs intercept at point -4 and 7, and that would be the same result we obtained using our calculation. So we have 3 cases here. We need to make sure we all can follow. The first one, case number 1, when absolute value of something is equal to k. We talked about that already. That means absolute value of this expression would be equal to plus k and minus k, and we solve for them. The second case, I'm going to make this a little easier. If I have absolute value of x is greater than, let's make it 2. That's what that means. That means all the numbers that are larger than 2 units away from 0. That's what it means. The number that are larger than 2 units away from 0 would be all the number to the right of 2. So all the number that are greater than 2. And all the number to the left of -2. So since we're including the endpoints, let's just make this equal to also. So in this case, means all the number that are greater or equal to 2, or all the number that are less than or equal to -2. And that's exactly what we're talking about here. If you have absolute value of expression is greater than k, means instead of x, we are having an expression. Means ax plus b is either greater than k, like in this case, is greater than 2, or ax plus b is less than minus k, like if we have minus 2. So it means the solution would be to the right and left of this number here, this number k. All the number to right or left, all these are larger than this 2 units away from 0 in this case. Similarly, if I say absolute value of x is less than 2, that means all the number that are less than 2 units away from 0. What are numbers are less than 2 units away from 0? That would be these numbers here, in between -2 and 2. So the solution would be all the number between -2 and 2. So if I change this x to the expression like ax plus b, so if I have absolute value of x plus b is less than a number k, means all the numbers that are in between k and minus k. Okay, so let's take a look at some examples. We want to solve absolute value of 2x plus 1 is greater than 7 and also less than 7. Greater than 7, remember the greater, you can always go back to your simple example. Just ask yourself, if I absolute value of x is greater than 7, what's that mean? That means all the number that are larger than 7 units away from 0. So all the number to the right of 7 and all the number to the left of -7 would be my solutions. So instead of x, we have expression. So you would say, instead of saying x is greater than 7 or x is less than -7, we would say 2x plus 1 would be greater than 7. Like 2x plus 1 would be greater than 7. That would be one condition we have to meet. Or 2x minus 1 has to be less than -7. That's exactly what we have here. So then we can solve for this individually and we find the solution there. It's a good idea to graph the solution after you write an interval notation and pick a number within those range and see if it makes sense. That would be a good test there. For the other one, this looks like that absolute value of 2x plus 1 is less than. So that would be like, a simple example would be, if I have absolute value of x is less than 7, means all the number between 7 and -7 should be the solution. So instead of this expression, this x, we have this expression. So we write that 2x plus 1 has to be between -7 and 7. You solve this and you get the range. And again, you can easily check your answer. Pick a number within the range if it makes sense, or pick a number outside the range that shouldn't make sense. That would be a good test too. So the solution would be all the number between -4 and 3 in this case. You can use your calculator to confirm these results. So in this case, if you graph y1 as 2x plus 1 and the second function is y2, the graph of y1 lies above the graph of y2 for values less than -4 or greater than 3. So in this case, we confirm the exact same result. All the number to the right or left of these intersection would be the solution. Same thing as we calculated. Okay, so here we can do the same thing for the other case B. Once you graph this, that would be the solution would be, the result would be all the number between these roots would be -4 and 3. The graph of y1 lies below the graph of y is equal to 7. So that the solution would be the same as what we calculated. Solving absolute value, continue with that, solving each equation or inequalities, then use the graphs. So in this case, if y1 is equal to absolute value of 4x minus 3x and y2 is equal to 2, then if you look at the graph of absolute value of 4 minus 3x here, which is right here, and the graph of y is equal to 2, if it's equal to, the solution would be where these two graphs intercept, as we calculated. If it is greater or equal to, that would be outside these roots. The first case would be, like we calculated, x would be equal to 2 over 3 and 2. And if it is greater than, we just said this would be outside the roots, would be to the right or left of that. And graphically you can see that all the numbers to the right or left of this root would be the solution. All the number from negative infinity to 2/3 and all the number from 2 to infinity would be the solution. And if it's less than, would be the between the roots. We said all the number between -2 and 2, we calculate that, and we can also see that on graph that all the number in between these roots would be the solution. All the number between 2/3 and 2 would be the solution. Solve its equation of inequalities. All right, these are the special cases. The first one have absolute value of x minus 2 is equal to -1. Okay. Now, we know the outcome of absolute value of x minus 2 must be always a positive number. We know this is going to be a positive number. Is it true that a positive number can be equal to a negative number? No, because regardless of what I substitute for x, the left-hand side would be always positive. That cannot be equal to negative. So that in this case would be no solution. The second case, the outcome of the left-hand side still is positive. Can I say a positive number is less than -1? A positive number cannot be less than -1. So it still is no solution. Next one, we have outcome of left-hand side is positive. Can I say a positive number is greater than -1? Yes, always true. Doesn't matter what I substitute for x, the outcome would be positive and that always would be greater than -1. So the solution would be all real number in this case. And we can easily see that on the graph too. If I would graph this, you can see there's no point of intersection between these two graphs. That's why there's no solution here. Now, if you have absolute value of expression is equal to absolute value of that expression, another expression, to solve this type of problem here, like in this example, absolute value of x plus 6 is equal to absolute value of 2x minus 3, you can just ignore the absolute value sign on the right hand side and proceed. Then you would say, in this case, means absolute value of x plus 6, if this is equal to 2x minus 3, then you can, one condition would be x plus 6 is equal to 2x minus 3. That's first case. And then you say x plus 6 is minus 2x minus 3. So I'm kind of ignoring this absolute value and proceed with the same method. Remember when I said absolute value of x equal to k? I have two cases, x equal to k or x equal to minus k. So my k is really 2x minus 3. So you would say the left hand side, whatever it is, x or x plus 6, would be either equal to plus 2x minus 3 or equal to minus 2x minus 3. And then you solve these and you get x equal to 9 and minus 1, and these are your solutions. And we can easily confirm the results also using your calculator. So in this case, y1 is absolute value of x plus 6, y2 is absolute value of 2x minus 3. So the equation y1 is equal to y2 equate to y1 minus y2 is equal to 0. So this would be a new equation. We call it y3, let's say. So this would be absolute value of x plus 6 minus absolute value of 2x minus 3. So if you do graph that, and you can see the point of intersection, these are the points, -1 and 9, that would be the same result that we obtained using our calculation. Okay, similarly, if you were going to solve absolute value of x plus 6 less than absolute value of 2x minus 3 or greater than or equal to, we can use your calculator to obtain that result. Again, if I assume the left hand side is y1 and the right hand side is y2, so this is really is y1 minus y2 is less than 0 or y3 less than 0, and then if you graph that, and you can see the solution would be either from -infinity to -1 or from 9 to positive infinity. Same results, it would be outside these roots. And if it's greater than, that would be in between. All the number between -1 and 9 would be the solution as we calculated. If we want to solve absolute value of x plus 5 plus absolute value of x minus 3 equal to 16 graphically, okay, we can let y1 be equal to x absolute value of x plus 5 and plus absolute value of x minus 3. We input that into our calculator, and your second function would be y is equal to 16 or y2 is equal to 16. As you can see, this line here corresponds to y is equal to 16, and this graph here corresponds to this y1. The point of intersection would be -9 and 16. So graphically you can find the solutions. The solutions would be -9 and 16. So let's take a look at this application problem. An aluminum can is designed to have a diameter of D of 2.5 inches with an error tolerance of not more than 0.02 inches. You want to write an absolute value inequality that describe all values of D that satisfies this description. So in this case we have to write the absolute value of something that correspond to this condition that they're referring to. All right, in this case we have the diameter D of 2.5 inches with the tolerance error of 0.02. So I need to add 0.02 to 2.5 and subtract 0.02 from 2.5 to kind of see what we're talking about. So the D must be in between 2.5 plus 0.02, which is 2.52, and on the other side must be 2.5 minus 0.02. That's the error that we have. So D must be in between these two, which is between 2.48 and 2.52. So if I go ahead and subtract 2.5 from this inequality, we do that because we want to have the right hand side and left hand side be the same number. So if I subtract 2.5 from each side, you can see D minus 2.5 then would be in between minus 0.02 or plus 0.02. Now, what does that describe? Remember we said if absolute value of something in less than a number, remember we said if absolute value of x is less than k, means all the numbers that are between k and minus k, all the number are k units away from 0. Remember that correspond to all the number in between negative k and k. Same idea. Instead of x, you have this expression here. So d minus 2.5, absolute value of that would be less than or equal to this value, 0.02. So this is the formula would describe this situation. Suppose that all values of f of x equal to 2x minus 5 must be less than 0.5 units from 3. Okay, how do you write that? Less than 0.5, so it would be from what? From 3. So you write f of x minus 3, absolute value of less than 0.5. That's how you write the equation. And to solve that, again, this means if absolute value of something is less than a number, would be this expression would be between, less than would be between these values. So you want to solve the absolute value equation. You say, what is f of x? It's given to me as 2x minus 5 minus 3 less than 0.5, or this case 2x minus 8 is less than 0.5. So in this case, I'm going to remove the parentheses here. I get 2x minus 5 minus 3. So here I get absolute value of 2x minus 5 is less than 0.5. Let's see what that means again. Absolute value of something is less than a number, means all the number that are between plus and minus that number. So absolute value of x is less than k, means all the number between less than k units away from 0. So it would be all the number between k and minus k. That's what it means. Okay, we're pretty much going to do the same thing here. So it means 2x minus 8 must be between 0.5 and minus 0.5. Okay, so we replace f of x with what we had here, minus 3 less than 0.5 means 2x minus 8 less than 0.5. We have to translate that into inequality without absolute value, which we did. And if I solve this, I have to add 8 to both sides of the each side of inequality and divide each term by 2. So that would be the values that we're looking at. X must be in between 3.75 and 4.25.